Morning, everyone. Hope you can hear me well. Let's go ahead and get this started. It's 11 o'clock. Just to introduce myself, I'm Blaize Stewart. I'm a senior consultant at Wintellect, and today we're going to be doing an introduction to Docker, and we're going to look at Docker at a high level and try to cover the full gamut of what Docker has to offer. If you can't hear me at any time, please do indicate that in the chat window, and if you're having a hard time, if you have a question, you can pose a question there, and I'll try to get to those at the end of the webinar here. And I want to save some time for questions at the end so that we can discuss this in more depth if you do have some pointed questions. But save those to the end because I want to get to the content first, and then at the end we'll have time for Q&A. So I'm going to start by talking a little bit about some upcoming webinars and trainings that we have concerning Docker. The first one is we're going to do another webinar on Azure Container Services, and this is a free webinar like this one that'll be on October 27th. And we're going to do some 2 days of intensive training, Docker head to toe, and it'll be very in-depth, very hands-on. We're going to have several labs and a lot of in-depth training on Docker, from everything from working with a Docker client to setting up Swarm and working with images and containers, and a lot of code samples, and we'll be doing that over a 2-day period, and that's $799. You can sign up for that. And on December 8th, we're going to be looking at Windows containers on Server 2016. It's an upcoming feature, and Server 2016 that's much anticipated. That's also using Docker as well. So we're having a lot of offerings this season concerning Docker and everything as it relates to that. And you can get more information about these webinars and trainings at wintellect.com. Just select training and then go to public schedule there. And you can find out a lot of information about other services that Wintellect has to offer and other trainings that we have related to other technologies as well. So let's go through our agenda for today. The first item of business that we're going to talk about is just an overview of Docker, and this is going to be some slides where I'm going to address a lot of what Docker is trying to solve and the architecture behind containers, and then the actual Docker ecosystem and everything there. Then we're going to look at 3 live demos. I'm going to be working with a demo application, and I'm going to deploy that application through a container, and then we're going to work with that same application to build images, and then we're going to then look lastly at Docker Swarm using the same application. So that's our agenda for today. So let's start by doing an overview of Docker. The overview of Docker is, like I said, we're going to look at what is it trying to solve. So what is the problem that really Docker's getting at? What is it trying to solve? This is oftentimes when I sit through Docker webinars and trainings, it just goes right to the technology, which that's not necessarily a bad thing. But I've always, and when I first got exposed to Docker, I was like, really, what is Docker trying to do? What is it really trying to solve? And what is this technology stack really addressing? Is there a problem? Is there something wrong with the way we've been doing things? And the answer to that is, well, yes and no. I mean, there's tools that do a lot of different things, but one thing that Docker is trying to do is become a DevOps enabler. And the entire DevOps movement was in response to the Agile movement. And if you know anything about Agile, it came out in probably the early 2000s, and then it's just grown ever since then. And the idea behind that is to have tight time boxes around build, test, plan, and code, and you do this in sprints and when you're building software. And so what happened with operations is they got a little overwhelmed with all these changes that were coming out of development shops, and they thought, is there a way that we can have an agile methodology that'll work for both application development and for operations? And what happened is they came up with the merger, essentially, of operations and development working together through the entire service lifecycle of an application, from design all the way through production. So instead of going from test to plan or test to release to plan, they were going release, deploy, operate, monitor, plan, code, build, test, and then you do this throughout the entire application life cycle from inception all the way through sunsetting the application. The second problem that Docker is trying to solve is this idea of microservice architecture. Now, microservice architecture was a response to a lot of the more heavy style architectures that were employed whenever web applications were starting to come out and become popular, and they were very monolithic, what we call interior applications, where the entire application was just one application you would install on a server, and everything was bundled into that one install, and it all ran on the same box. Well, in response to that, it became hard to update and maintain that application because all the components were tightly coupled together as an application was concerned. So they took the ideas out of object orientation, tight cohesion and low coupling, and applied that to the service level, and they came up with this idea of microservice architecture. It's where a single application is deployed as a suite of small services, each running in its own process and communicating with the lightweight mechanisms such as HTTP and APIs. So what you end up with is that you end up with a single application that's really a mashup of services that look like this. So each one of these services is independent of all the other services in the application, and they're communicating via HTTP. And these are built around business capabilities, and they're deployed through automation. And so what Docker's doing is attempting to give operations and developers the ability to deploy each one of these services as containers and then automate the deployment of those through a lot of the Docker ecosystem and a lot of the Docker tools. And so that's really what where Docker comes in, is it gives you the containers that you wrap the components in, and then it gives you all the tools you need to orchestrate and deploy an application as a containerized application. And that's what we're going to look at, is how does that actually happen using Docker. So these are the problems that Docker is trying to solve. However, let's look at how they do this architecturally, and then you look at some of the tools that they use to do this. So before we do that, though, I wanted to look at some survey results that came out this year. Docker did a survey of 500 technology companies, and I really just want to focus on 2 or 3 of these. The first one is that 45 of the respondents say they are able to release apps faster by using something like Docker and the Docker tools, and they also saw a 13-fold increase on the frequency of software releases. So rather than deploying monolithic applications where you have more scheduled, longer times between scheduled releases, they were actually doing this more rapidly and also doing it more often. So the idea of continuous integration and continuous deployment becomes more of a reality whenever you start to build out applications using Docker, and that's what Docker found. Here's another interesting statistic, is that when polling these folks, they came out with that 44% are adopting microservice architecture, and then 78% plan to use Docker to facilitate that, to build microservices. So Docker is finding that people are really using Docker as it was intended to be used for deploying applications and containers and doing more rapidly, as you would with DevOps, and also to answer the microservice architecture question. And then here's an interesting one I just wanted to point out, is that 78% of the respondents said they plan to use Docker to containerize existing legacy apps. That's not really what Docker was intended to do, but it is able to take an existing monolithic application and deploy it as a legacy, deploy it in a container as a legacy app. And many of them are committed to modernizing those applications using microservice architecture, but they are taking the containerized approach to deploying legacy applications on Docker. So it does give you the ability to do that. However, it's really not what it was built to do, but it can do that. And as you see, as we work through some of these slides, you'll see how it can do that. It's just not the intent behind Docker. So with that in mind, let's look at the actual container architecture. Now, what the container architecture intends to do is eliminate some of the overhead so that you can actually deploy applications in a more lightweight and quick fashion using some of the technology. So what Docker is designed to do is take a container and wrap up a piece of software with everything that it needs, runtimes, code, and everything, system libraries, anything that you could install on a server. And that's, as they say, it guarantees that it will be the same in every environment regardless of where it's running. So what they do is, what Docker does is it inserts the Docker engine on top of a host operating system right here. And this abstracts out the underlying operating system and exposes it to the application. So it's, in a sense, virtualizing the operating system rather than virtualizing hardware like virtual machines do here on the left. So by inserting this smaller middleware here, it eliminates the need for these guest operating systems to be installed. So you reduce the overhead by eliminating the guest operating systems. There's a small increase in terms of what you have here versus having multiple operating systems to run applications. It enables you to still run the exact same applications, but you see a lot less in terms of CPU cycles and memory usage and disk space whenever you eliminate those guest operating systems that would otherwise be running on top of virtualized hardware. So that's how it's able to do it. So the container architecture still gives you the same kind of isolation you would expect from a VM without having to have the overhead of an actual VM running. So that cost savings does come with some paradigm changes, though, whenever you start to look at deploying applications as containers. So with that in mind, though, what it did with security for containers for applications is what it looked at to reduce the attack surfaces of applications by isolating the applications and to only the required components and interfaces and the libraries and network connections. So whenever you eliminate the underlying operating system support an application, you're reducing the attack surface for that particular application by eliminating things like drivers and kernel exploits or other system libraries that aren't necessary for your application to run but might be necessary to get your host operating system up and running. So none of that's in the container. All that's in the container is the absolute essentials that you need to run that container. So in doing so, you actually increase your security by doing that for that particular application, and I think you'll see that, and when we actually do some demos, that we're not going to be installing a full-blown operating system to deploy these containers. It's just bare bones, absolute essentials, and once you have that, it makes your attack surface much smaller. So whenever you have a container, you have to rethink about how you deploy applications. The first thing that you have to do is really, you want to think about what you're doing with the container itself. So a container, by design, what is intended for to run in the container is a single service. So with getting back to that idea of a microservice, the idea is that a container runs a single service. So there's nothing else outside of that service that's really running inside of the container. So whenever you're running a container, you might want to run that single service in a container when it requires complex configurations of a particular versions of libraries or complex dependencies for that service. You probably wouldn't want to use a container when a simple shared hosting would suffice. In other words, if I can deploy this, my application, it's a small app, and I can deploy that, say, on Azure Apps, web apps, and that's how I'm going to deploy it. I don't need a container to do that. However, if my app requires a lot more than what Azure Web Apps can do, then I might take that and stick it into a container. Or my application has multiple levels inside of that application, and the actual web app isn't sufficient to host all of those particular components, then I would go to containers for that. So yes, I would put a dividing line between the, containers and shared hosting at that point. There's also the idea of application components that don't need a full VM or a physical VM to run. Applications sometimes will require that you have full access to the VM or full access to a physical machine to run. For instance, if I'm building an application that controls a CNC mill, or I'm building an application that controls an X-ray machine, a container wouldn't be a good use for that because that needs to control hardware and that's attached to that physical box. Or if I'm running a rather large monolithic application, and that monolithic application requires all the resources dedicated to the VM. I'm not going to see any gain or benefit from putting that into a container if it requires the entire resource of a VM or multiple VMs for that matter. So I might not really want to containerize such an app if it's a large-scale monolithic application. You just probably want to just install that directly on top of the virtual machine in which it's running, because you're not going to see the benefits of of lower memory footprints or fewer CPU cycles, because you're probably only going to have one container running one monolithic application if you put it in a container. And then also, you do want to use containers to run components in separate containers, but you don't want to run multiple applications in one container. While you can do this with containers, you can actually take a container and install 3 or 4 applications in one container. That's really not what containers are designed to do. The idea behind containers is to break that up. And run each one of your applications or your application components in separate containers. So the idea of one service per container, you don't lose anything by breaking it up in containers. Actually, you gain a lot of flexibility by doing that. You might lose a little bit of disk space, but you don't really increase your memory footprint or any of that kind of overhead by breaking up containers, breaking up applications into multiple containers. So that's often a common mistake for folks that are actually getting used to working with containers. They just want to use them like a VM. Hey, I can throw everything in a container and I'm using a container. Well, that's really not what containers are for. It's the idea of break it up into multiple containers and then deploy those containers independent of one another. So that's how we deal with containers. That's when to use containers. Now let's talk a little bit about the Docker tools and how they actually work to accomplish this vision of deploying containers. Now this architectural diagram here I have on the right is very simple, but you have basically 3 components working together. You have the Docker client, you have the Docker engine running on a Docker host, and you have Docker Hub. And this is the Docker ecosystem, and these each represent one of the major components of the Docker ecosystem. Now, most of the time when people are talking about Docker, they're really talking about the Docker engine running on a Docker host, but you have a lot of other stuff that's value-added services around that. And one of the first tools that people get introduced to when they're talking about Docker is Docker Machine, and this is actually used to provision Docker engines on Docker hosts, which you'll see right here. So you will run Docker Machine, which we'll look at in a moment, and then spin up a Docker host, which will then install a Docker engine on that host. And the Docker engine itself has the ability to build images, and we're going to talk a little bit more about that, and then run those images as containers. So a container is actually an instance of an image, and so you can have a single image and spin up 20 containers or 200 containers from that image. So Docker build and Docker run are part of the Docker engine. The Docker client, which is what you use to interact with the Docker engine, runs on your local machine. So if you're running Linux or Mac or Windows, Docker provides a Docker client that is compiled for each one of those platforms, and it's a remote client that will connect to a Docker engine over a network, and then you can control the Docker engine using the Docker client. And then there's Docker Compose, which is a wrapper around much of what you can do inside of the Docker client, and then it acts as a way of orchestrating complex applications for multiple containers. So this gives you the ability to build out scripts essentially for multiple container applications like we were talking about for microservices. So it's an orchestration engine, and it also gives you the ability to automatically build and deploy those images using Docker Compose. And lastly, there's Docker Hub. Docker Hub is a value-added service where most of the images that are publicly available in Docker are hosted. So whenever you run the Docker client and you actually go to run your first image, you're going to pull that image from Docker Hub. And then when you build images right here using Docker Build, usually those are going to be based on an image that you get out of Docker Hub. So you'll pull an image from Docker Hub and customize it to your Docker Build. And then Docker Compose just builds on top of Docker Build using multiple containers. And we'll look at all of these components working together in conjunction to build out this vision that Docker wants to have not only containers, but all an ecosystem of tools around containers to enable DevOps and microservices. And then lastly, it's not on this diagram here, is Docker Swarm, and this is the clusters of Docker engines across multiple hosts. So this gives you the ability to have redundancy and high availability on Docker hosts, and we're going to actually run and have an instance of Docker Swarm running in the cloud that I'm going to demonstrate later on in one of the demos. So that's the Docker tools. So let's we've talked a lot about an overview of Docker for the last 20 minutes or so. I want to dive right in and do a couple demos here. The first one is going to be the Docker Hub and the Docker client, so you can use peruse Docker Hub and then use the Docker client to pull down images using Docker Hub. So let's go ahead and switch over. I'm going to get out of PowerPoint here and let's let's go through this slide real quick and look at Docker Hub as a repository of images, like I mentioned earlier, and it's available at Docker Hub, hub.docker.com, and then the documentation is there on Docker Hub. So let's flip over to Chrome here, and let's go to docker.hub.docker.com, and this is the homepage for it, and you can log into Docker Hub and you can create an account, but you don't have to have an account to pull images from it. But if you want to push images to Docker Hub and use it for your image repository, you'll need an account for it. But if you want to find an image, you can just search up here. So I'm going to search for Nginx, and that's a very popular one. It's been pulled 10 million times. And on each of these pages, you want to look for a couple of things. If it's official, this is the official build of that particular image. So this is the official Nginx image from the folks that maintain it. And you'll have a lot of other folks that have built versions of it, but the official one's here. So if you want to stick to official ones, they'll get periodic updates, and you'll also have a lot better support probably. And but you can use some of the other images if you like. And this will also give you an MD file that actually shows you how to use the image and all the documentation. So you can't get this from the CLI, so you'll want to use Docker Hub to pull up the details of the particular image you're wanting to deal with. And this particular one, they're all going to look a little different. So they all have different ways of getting these up and running, but they're all built around some of these Docker components. So here I have Docker run, and this will just give me some bare bones way to get this up and running. What this is doing is using what they call Docker volumes to mount content into the image, and then it will use the Nginx will be installed in the image, but it'll have an external volume to where it can serve the content from that external volume. And there's other ways to do this. You can also use build a Dockerfile to build a custom version of this Nginx and do that. So it gives you all the documentation you need to get this up and running. So let's do a little demo here. And with this, so I'm actually going to pull this Nginx. But before I do this, I'm going to use a Docker machine to show you what I'm running on my local dev box here. So Docker machine is what I use to deploy all of these. So if I wanted to create a new one, I would go Docker machine create and create a new machine. And these are all running on VirtualBox on my local machine here. So I'm going to be interacting with a Docker engine on a virtual machine running on my local laptop here. So, but what I can do with Docker machine is I can set up the environment that I'm working in using Docker machine. So I'm going to go Docker machine env, oops, I'm going to go demo machine, and this is my demo machine, and it's going to spit out some directives here that I can use to copy and paste, and this will provision my environment to use that particular Docker instance that I'm running. So if I do, what this is really doing is just setting environmental variables. So if I come over here and I look, I have all these environmental variables that are set per that command I just ran. It says run this command to configure your shell. Okay, I copied and pasted it, and it sets some Docker environmental variables there. That's really all it's doing. So this is actually my Docker host. That's the IP, and I'm going to need that IP whenever I pull up things that are running on this Docker engine. So let's come down here, and let's run some Docker commands. So let's see what I have running on this. So Docker ps-a is going to show you all of the containers I'm currently running on this particular box. And right now I just have one image running on it, a container running on a MySQL instance. So let's do Docker pull, and I'm going to pull that Nginx image, so Nginx, and that's going to download from Docker Hub Nginx, and I'm going to extract it. Now I'm going to come back over here and look at Docker Hub and look at some of the documentation of it. So let's just say Docker run name some Nginx -d and then this P. I'm interested in that. What that's going to do is expose a port. So let's do that. Let's go Docker run, and this is going to run that Nginx image. So I'm going to give it a name. I'm going to call it name. I'm going to call it Nginx demo, and then I'm going to give it a port, and I'm going to expose port 8090, and I'm going to point that to the internal port of the container, which is port 80, and then I'm going to tell it what what image I want to run, and it's going to be I can't type this morning, Nginx, and that will actually just run a bare bones instance of it with a port 8090 port forwarded to the internal Docker port of port 80, which is going to be running on Nginx. So let's run that and see what happens. So now it's up and running. Let's go over back to Chrome and let's see if I can pull that up. So 192.168.99.101 port 8090, and it says welcome to Nginx. So I just did a simple pull of that image, and then I did a run of that image using the Docker run command. So that's Docker Hub. You've seen the Docker Hub, and I use Docker Machine to connect to a particular instance of that of Docker engine running on a Docker host, and then I used the Docker run command to actually pull and run that image. So that's what I've been doing here. So let's go on to our next demo here, building and deploying images. So this demo, what I'm going to do is I'm going to actually work with an application that I have running on my dev box here. I built a little simple Node app, and then that little simple Node app is going to use containers to run in after I build the image and then run the image. But I want to go over what I'm going to be using behind this. So this is going to be using what they call a Dockerfile. And a Dockerfile is a text document that just contains instructions that are interpreted by Docker build to create an image. So the convention goes like instruction, then you provide an argument to that. And the instruction in the Dockerfile can build images from existing images by importing files and executing inside of that image. So that's what I'm going to be doing with a Dockerfile, and I have some samples of these we're going to look at as code. And then I'm going to use Docker Compose to build a more complex application using 2 images and 2 containers to run that application. Docker Compose is a tool for building multi-container applications, and it uses a Docker Compose file, and the Docker Compose file will then look at multiple Docker files and then build custom images and then deploy those images as a unit to where I can have an entire application defined by multiple containers. So that is the vision behind Docker Compose. It's very just basically a wrapper around what you can already do with the Docker client manually, but it gives you the ability to orchestrate and automate a lot of what you can do with the Docker client. So let's go back over to my command prompt here, and there's a log that was spitting out from Nginx. So I'm going to go to D:, that's where I have my app, and then you'll see source, and I'm going to go to intro to Docker, and then in this I have my Compose app here, and in this I have a couple of different files. I have a Docker Compose, a YML file or YAML file, and this has got 2 directories under it. So I'm going to go cd app, and this is my application, and this is using this is a Node app running that I can run, and it's got a Dockerfile, and the same is true for that database. But just show you this application running on my local dev box here, I'm going to start it using node index.js. And okay, now I've already got a container running that's running a MySQL database engine, so this is actually just going to take advantage of that MySQL database engine that I'm running in a container, and it's listening on port 80. So this is actually running on my local dev box here, so I'm going to open up my browser and point it back to localhost. And what this app is doing is it's taking the lat long out of the viewable box here, which you can see on the browser window, and as I scroll, it's changing the bounds of that lat long, and so it's going to a database that I have on MySQL and querying that database with the bounds of this window here, and to get all of the lat long for the airports that will show up in this particular window. So as I drag, it's just running a number of queries behind the scene. So to show you those queries, it's just doing a lot. I'm just spitting out the select statements to the console window here. So as I drag that, it's just running more and more queries against that database. So, and if you zoom out, it does the same thing. So you can get lots of lat long queries into that database. So that's what this app is doing. So I'm going to go ahead and terminate this application, and I'm going to deploy it into a container. So let's go look at the Dockerfile for this. So I'm going to go File, Open, and let's go back over here to this and go into that application I have here and look at the Dockerfile for it. Now, what this Dockerfile is doing is it's using this from directive here to say from this particular image up on Docker Hub. Now, this is using a node, and if this is a tag to a using node for, and this is using an on build. This particular image is designed to take the node app that I'm running in, and once I create this image, it will automatically read the package.json file and then deploy and install all of the dependencies for that application into the image automatically, and then it will look at the start parameter on that package.json and call that whenever when I start that as a container. So I'm using two dependencies here. It's going to install Express in MySQL, and then it's going to use that command there, node and index.js, when it actually launches this application and when I launch it as a container. So let's build this image using the Dockerfile. So if I go Docker, I'm going to call Docker build. I'm going to say, give it a tag name. I'll call it demo-image, and I'm going to specify no cache because I don't want it building caches between each build. And then I'm going to say use the relative path to where I'm at. I'm currently in app, and it's going to build based on that. And you can see it's running npm there, and that's where it's installing all of the dependencies for this particular application. These steps right here set environmental variables. Now this is gonna die. It's not gonna work for one reason right here, because this environmental variable that I set right here is pointing to the wrong host. So if I actually run this application, it's going to throw an error. So if I wanted to reconfigure this application, I would set the environmental variable to 101 because that's my Docker host. And to show you what the actual app is doing, it's actually reading in environmental variables that I would otherwise set in my environment, but with a Dockerfile, I can override the defaults by setting environmental variables here, and these get set in the container. So whenever the node goes out there and looks for this environmental variable called MySQL host, I can set that in the Dockerfile, and it will take this one rather than the default, which I had set to 101. So if I rebuild this image using that new Dockerfile, let's save that out, make sure I saved it, it will work. So if I change my host to 101, that environmental variable will then be included instead of the 99.100 will be set to 99.101. So now that the Docker image is built, I'm going to go Docker images, and you'll see here I've got a number of images already on here. And there's the image I just built called demo.img. So I'm going to go docker run. I'm going to run that docker run command again, and this time I'm going to specify a name. I'm going to call it demo-app, and I'll do another port, and I'm going to say that port is going to be 8080, and I'm going to forward that to the internal port of port 80 because that's the port I'm listening for on Express. And then I'm going to specify my demo image here. And so this is going to spin up my custom image on Node.js with a port 8080 ported to the internal port on that container. And see, I've got a listening on port 80, and it should be up and running, but I'm going to point it to port 8080 because that's the external port. So if I go to 192.168.99.101 and I go to port 8080, I get the same application, but this time it's running on my container instead of my local box, my local dev box. So it's the same app, it's running the same code, it's just this time I'm running it inside of a container, not running on a dev box. Now that we've seen the build process using a Dockerfile, I can now orchestrate that with Docker files and Docker Compose files. So what I'm going to do with the Docker Compose files, I have that over here. I'm going to go back over here and look at this Docker Compose file. Now Docker Compose allows you to define suites of images and containers that are running. So here I'm using a YAML file or YMI, a YML file, and this uses indentation for notation rather than brackets and all that. So it's not really a markup language. It's really for defining. It's a structured document without using a lot of extra markup like what you'd see in JSON or XML. It's a simpler form of what we call a subset of JSON, but it's something like it. And what you do is you specify blocks by indenting it more, kind of like what you do in Python or something like that. So here I've got two services that I want to deploy using this particular Docker Compose file. Here I've got my database and I've got my app. Now what this database service is saying, build from this directory here. So this database exists, that's the database directory underneath where this Docker compose.yml file exists. So I can specify other paths there, but that's just a relative path to that particular path. And then this is pointing to that exact same app folder that I was doing, just looking at there a moment ago. Now, for this particular app, what I can do is I can override the environmental variables here inside of that Docker build file as well. So here I'm going to set my MySQL host to use database, the name of this particular service here, and instead of the actual IP address. And these are all the defaults that I'm pushing into the port, user, password, and database that I'm using. Now let's look at the build script on this database. It's another custom Docker file. It's very simple. This one is doing much like the Node app does, and for this particular instance of MySQL, what it does is I can use the copy directive in this Docker file and copy into the special directory on this container. And whenever this container builds, it looks for any files inside of this directory, and whenever it finds them, it'll actually execute whatever's in that file. So I've got this airports.sql file where it creates a database and inserts a table into there with all the geolocations of airports. And so that is what's inside that SQL file. I'm not going to go into the details of that, but that's what it's doing. So let's run this Docker Compose to get out of, to deploy these automatically. So if I go ls or dir, I'm on Windows, not Linux, and if I go Docker Compose and I say up, what it's going to do is it's going to read this Docker Compose YAML file, and then it's going to build the images and containers. Oh, I have an issue, and the reason why is it's unable to deploy that because I already have a container running on that. So I need to remove that container that I was running before that was mapped on port 80. So let's go docker ps-a and see this container right here is already running when I run that demo. So I'm going to go docker rm-f, I'm going to say demo app, and then I'm going to run docker compose up, and then that should start my apps. So now that I have these apps up and running, I should be able to go back over to this, and this is running in a separate container, except this time I deployed the MySQL image and the Node.js image at the same time using a Docker compose file. So that gave me the ability to do orchestration on both of those images at two containers. And because I've already built them, they were already in the local repository, so it just deployed from there. So here we've seen Docker build and Docker compose as a way to go from images to containers, how to build custom images and then take those images to combine them together to make full-blown applications using container technology. So let's go back over here, and we've looked at Docker Compose and Docker Compose. Now I want to do one last demo, and this one is using Docker Swarm. Now Docker Swarm is another technology that comes out of the Docker camp that is used for providing the ability to cluster Docker hosts and build out Docker scalability as well as availability on a cloud provider, or you can do it on-premise depending on what context you're dealing with. Now there's a lot of what they call containers as a service out there. Google has one, Amazon Web Services has one, Azure has containers as a services, and even Docker themselves are doing containers as a service. Now the ones that use a pure Docker implementation are the ones that are going to use Docker Swarm as a way of doing clusters and high availabilities and redundancy across those clusters. And what you have here is a similar diagram to what we had before, but instead of having a single Docker engine running on a single Docker host, what you do is you connect your Docker client to a Docker Swarm manager, and that Docker Swarm manager then connects to Docker Swarm nodes that are all running across multiple machines on your cluster. So you need the manager to orchestrate the nodes. So with the one I'm actually going to be using is on Azure. I'm going to be using Azure Container Services, and it uses, one of the options is to use a pure Docker implementation. So I'm going to run the same demo, the same Docker Compose on Azure Container Services using Docker Swarm manager and nodes on that particular instance of Docker Swarm. So that's what this demo is going to be for. So let's flip back over to, let's go back to my desktop here. I'll need to launch PuTTY here to connect to that cluster. Now I'm going to need this URL right here in a moment in order to pull that up. So I'm going to launch this and open it up, and I'm going to log into my Swarm Manager. Now with this, what the Swarm Manager is doing is I'm actually SSHing into that particular box on Azure, but I'm also creating an SSH tunnel through this particular SSH session that is going to port forward a local port that I'm running on my local dev box here to that instance of Azure Container Services. So I'm going to open up a new window here, and I'm going to set my Docker host. I'm going to do a set Docker host, and I'm going to set it equal to, I'm going to get the same syntax that this uses here. So if I do set, I want the environmental variable that looks exactly like this one right here. So I'm going to take that and copy and paste it here. But I'm going to change the port number to 22365. So, and then I'm going to change the IP address to localhost, because what this is doing is I have this port right here running on my localhost is exposed by SSH, and then it's going to intercept that traffic, put it on SSH tunnel, and then forward it to my Swarm manager, which is running on Azure, and then it's going to decrypt it up from the tunnel there and then forward it on to port 235 or 2375 that's running on side of the Azure virtual machine. So once I have that, I should be able to execute Docker commands on this particular instance. And since there's nothing running on this particular instance of Azure Container Services, but what I can do is I can run the exact same commands using this instance of Azure Container Services, which is running Docker Swarm. Just to show you that I'm running a cluster here, if I do Docker info, it's going to give me information about my Swarm here. So I actually just have a small setup here. I'm running 2 nodes. I'm running just 2 small nodes on Azure, and I'm doing this for demo purposes, and each one of those has 700 megs of RAM and 1 CPU, and the actual Docker Swarm Swarm manager is running on a different machine, but the Swarm agents are running on a scale set that is a VM scale set on Azure. So let's go over to my app and run that same command I did a minute ago, that Docker compose up, and get into this app and see here I'm into my compose folder. So I'm going to go docker-compose up, but this time instead of running against the Docker host on my virtual machine running on my dev box, this is going to run this same YAML file on Azure. So it might take a little bit longer to actually get this up and running, because what it does is, in the process of doing this, it's actually bundling all of those directories into a zip file, uploading that zip file to Azure, then unzipping it, and then actually building it on Azure. So it's running some stuff out there, and it's building out that MySQL container. That's what that's doing right now. And there it's doing, and it looks like waiting for it to tell me it's actually running. Okay, it's up and running now. So it built that container. Everything looks good. I think my application is running. So now what I need to do is go get the IP address, not the IP address, the host name, for the load balancer. And now cluster, I think this should be agent, MGMTs, change this to cluster management to cluster agent, and then put, there it is, and there's my app. And so I'm running demo cluster agent, and now I'm running this on Azure instead of running it on my local dev box. So if I wanted to deploy an application to Azure, I could use containers to do that, and it would do it rather rapidly. So if you can imagine for a moment, I'm working on a dev box here, working on a Node.js, I got everything running. My QA environment might be my local virtual machine, or a virtual machine I'm running on some local box here, and then I have my production environment would be Azure Container Services, and that's whenever I'm ready to run this application, I can just push it to Azure Container Services straight from the same environment. So I'm running the same container across QA and production, but I have high portability between each one of these, and I'm running the exact same code, exact same configuration, exact same everything. The only difference between these two is location. So this is why folks are really latching on to Docker, because it gives you the ability to have rapidly deploy software without having to have a billion and one configurations for every environment that you're doing. All you have to really worry about is, especially if you're using containers as a service, is getting your containers working. And once you have your containers working, you can guarantee they will work the same way in every environment. So we've done our Docker Swarm demo, and that's the last live demo I had. I just wanted to open it up for questions if you had any. So let me unmute this, and maybe we can get some questions going on here if you guys had any. Let's see if I can unmute all of these. Let's see. If you have a question, go ahead and type it into the chat box, and I'll see if I can answer that. It says I'm having the mute function doesn't seem to be working unless I do it manually for every user. So if you have a question. Yeah, we'll have the slide. We'll put the one of the questions is can you share the slides? We're going to put these up on Wintellect now under our Dev Center. All the code samples and the recording of this webinar will be available on Dev Center, so you can review this later. So we are recording this. Let's see if I have any more questions on here under questions. Okay, I see the folks asking about the webinar thing there. I can't hardly see this. This is there we go. All right, here's some questions that are coming in. Can you give an example of where containers are used in public today? I know that I personally worked on some projects with a lot of with some clients that are actually using containers for non-disclosure agreements. I can't tell you who those are, but I do know that they are using it. I do know that there are a number of companies, big companies out there that are really using these heavily. If you want to get a list of those, you can go out to docker.com and also use and to see a list of those customers that are currently being used that are currently using containers. From this question, is it possible to set a Dockerfile on the number of processors or the amount of memory used by a container? Yes, it is possible to do that. I don't think you can do it in the Dockerfile. You can't do it in the Dockerfile, but you can do it in Docker Compose, and Docker Compose will set Docker up. Whenever you specify the run command, you can specify the number of CPUs, even fractional CPUs, to do that, and you can also set memory limits and things like that in Docker Compose. And you can also do that, I think, when you do the run command as well. Let's look at let's see. How does Docker stand out from Vagrant? Truth is, I'm not familiar with Vagrant, so that's a good question. I've never used Vagrant before, so I can't really answer that intelligently. I wish I could, because that is I'm not familiar with that environment. So, for example, Facebook, not sure what the context there is. How to use different configurations for different environments using Docker. Now, for different configurations for different environments, what you'd want to do is you could have multiple. That's where the Docker Compose comes in. If you had a different environment, you might want to use Docker Compose to configure your environmental variables, and then you use your Docker files to build your images, and then use Docker Compose to facilitate the different environments that you're running in. So you can specify in the Docker Compose, you could have like prod or your prod and QA Docker YAML files, Docker Compose YAML files, and then you can specify one of those whenever you're doing Docker for different demos. Any info on Docker Swarm mode and when 2016? Well, this is still in, I don't think it's available in the Windows Server 2016 yet. I haven't seen it because the last time I was looking at it was still in beta at that point for containers. However, that might not be a possibility whenever they do a final release of that, and I'll definitely look into that. We'll have an upcoming webinar on that, which I will be able to tell a lot more about that as the technology comes out, as 2016 comes out in the next month or so. Can images be hosted on-prem? Yes, you can have private repositories on-premise. That is possible. You can do that by actually using a container, or you can deploy that there's a special container that you would otherwise set up in your Docker environment that actually acts as a on-premise repository for images, and then you can configure your Docker environment to log into that local repository, and then you can pull from that local repository rather than pulling from Docker Hub. Is there Visual Studio integration? Yes, there is Visual Studio integration for doing development on containers. There is a package you can download and install on Docker, and on Visual Studio, and it gives you all the Docker. It gives you the ability to go deploy actually an image straight out of Visual Studio into a Docker image, and then deploy that image using the tools that are integrated with Visual Studio. Just Google Visual Studio Docker tools, and it's a download add-on you can add on to Visual Studio, and it works with all of the various editions other than Visual Studio Code. It'll work with any like community or enterprise, so you can do that. Is Windows Nano Server image versatile enough to run Linux containers and or run all container apps? Windows Nano Server image is designed to run Win32 Windows-based applications. So what it do is, if you have a .NET Core application or something that's going to be running on Windows, you would deploy that on the Nano Server image. Now, you wouldn't want to use Windows to run a Linux container. You just use Ubuntu, so you probably wouldn't use that for your particular application. Now, you would want to use Linux containers to run Linux apps, and then use Windows containers to run Windows apps, and that's an upcoming technology. It's still, the Windows Nano Server is available on Docker Hub. You can deploy it on Docker. It's not available. It's still kind of new, so I mean, so it's still, you might want to do some testing before you go into production with it. So, but yes, that is emerging technology, and it's really exciting because you'll now be able to run Windows as well as Linux-based applications on top of Docker. Were there any performance issues? Actually, they did some performance analysis of Docker, and there's very little in terms of Docker performance overhead that you would otherwise get from running Docker. I think you get the sum total of it was something around, you take a 3% hit by running something in a container, but overall it was very little compared to running it in a virtual machine. So they did like an analysis of deploying an application in a VM versus deploying it into a Docker container. What ended up happening is you got better performance out of running it in a container versus running the same applications across multiple VMs. So you get actually can get better performance out of running something in a container than you would otherwise running in a pure VM environment or something like that. Now, obviously, if you run your app bare metal, that's going to be better than a container. So basically, the old rule is that the more abstraction you have, the poorer your performance is going to be, because Docker's doing very little in terms of abstraction. It's abstracting more or less the kernel. You don't get a lot of that hardware abstraction that you get with a VM, so you get much better performance that way because you have less abstraction going on. Microsoft Azure Service Fabric versus Docker, which is better? That's not really it's a hard question to answer, because Azure Service Fabric it's not exactly apples and oranges there. Docker, you can deploy Docker. It's an upcoming feature with Azure Service Fabric. You can deploy Docker images to the Azure Service Fabric. Azure Service Fabric gives you the ability to deploy apps into the Service Fabric. It depends on what you're trying to do. So I don't, that's kind of an open-ended question. Which is better? I don't know. It depends on what you're trying to do, I guess. Now, if your app will run on Azure Service Fabric, and like I was going back to that slide where I was talking about do's and don'ts, you probably wouldn't want to, if you could run something purely on Azure Service Fabric with the assumptions that Azure Service Fabric has, you probably might want to go that route if you're having a smaller, leaner application. But however, Docker itself is designed more for more complex scenarios. that you might not want to, that would break the assumptions of Azure Service Fabric. But one of the upcoming features of Azure Service Fabric is the ability to run Docker containers on that. Now, there are limitations to that, so you can, the orchestration, for instance, becomes a little bit harder to do. Some of the networking and other things that you could otherwise do in Docker Swarm are unavailable, but at the same time, Azure Service Fabric, it does allow you to run, gives you the ability to run a pure Docker container on it, and that's an upcoming technology on that. There's a good demo out there on Channel 9 if you subscribe to that, where Jeffrey Richter, who is with Wintellect, does a demo of that, and he shows you how that is, how to do that. Nano can run on Hyper-V with containers. That is true. That is a true statement. I think Nano, there's two kinds of Windows containers that you have. You have Hyper-V containers and you have Windows containers. Now, the upcoming Windows containers environment is running. It gives you the ability to run they're based on Hyper-V, and so you can run traditional Docker containers, or you can run Windows containers or Hyper-V containers on top of that. So it gives you a little bit more versatility in terms of the kinds of containers you can run on top of that. But ultimately, it's using the Docker engine as the way of managing all of that. All right. And is it a good idea to use Docker to compare different database engines? Is it a good idea to use Docker to compare data? Is it a good idea to use Docker to compare data? I guess you could do that. Database engines being, assuming you're talking about, assuming you're talking like something like Postgre or MySQL or something like that, you could do that. You could do some benchmarking on that. Now, like if your application doesn't require that you deploy the database into a container, you could use database as a service, DBAS, on something like Docker. I'm sorry, on Azure or on Amazon Web Services. You could deploy a dedicated environment for running databases. But if your application is a one-off database where you only have like maybe one database and it's a fairly lightweight database, deploying that into a container probably wouldn't be a bad idea. But the main thing that you want to do when you're dealing with databases is make sure that your data persistence is a volume in the database, a volume in the container, not persisted as part of the Docker itself. Docker for Windows release now spawns Linux containers hosted inside our Hyper-V on Windows 10 Anniversary Edition as well. We'll see support for 2016 once it's released. That is true. That is a true statement. So we're up against 12 o'clock here, and I'm willing to continue on this this discussion if you guys have any more questions. But I thank you guys for attending. But it's 12 o'clock, so if you guys don't have any more questions, thank you for attending. I just want to wrap up by saying, remind you of the trainings that we have up. We'll have some training on the container services, Windows Container Services on Server 2015, and we're also going to be looking at Azure Container Services on the 27th. And if you're interested, we're going to have a much deeper dive into the technologies in the Docker stack coming up on October 20th and the 21st. So thank you for you guys for attending, and I appreciate your time.